All right, so in this lesson, we're going to do two things. We're going to talk about choosing the best method to solve quadratics, and I'm going to show you a fourth way that we haven't talked about yet. And then we're also going to talk about word problems and how to write quadratics and model them. It's a pretty easy format. So factoring, you all know that's always the first one that you want to try when you have quadratics. That's just where we're going to do top number, bottom number, where it multiplies and it adds. If that doesn't work, or if it doesn't seem to make sense, we might try square roots. That's when we just have an x squared in the equation. So no x term, just an x squared. Quadratic formula, that's kind of our last resort. It's not that quadratic formula is bad, it's just that it's long. So it will actually always work. That's the good thing about quadratic formula, is it will always work, where the other methods don't always, but it takes a while. And then calculator is the last one, and the best time to really use a calculator is when we're going to have word problems, or if we want approximate answers. So by approximate, I mean like decimals. Quadratic formula is good when we need exact answers, like when we need that square root to be left in there instead of just estimating what it is. So let's look at how to choose one more time between the best methods. So before we do that, I want you to go ahead and copy these problems down and just try for yourself, see if you can pick out what would be the best method for each of these. All right, so hopefully you've already done that. So I notice A just has an x squared in it, so the best method for this one would be square roots. And I'm not going to do that because we should know how to do that by now. I'm just labeling what the best method is. On B, I notice it's not square root because it's got an x term in it, so I'm going to try factoring. So I'm going to do top number is -7, bottom number is 4, and it shouldn't take that long for me to realize that that is not going to work. That's not a viable option, because I can't come up with numbers that multiply to -7 and add to 4. So this is one that I'm going to end up having to do quadratic formula on. C, remember when we check factoring, we need to move this to the end. So top number is 12 and bottom number is -7. And hopefully it doesn't take you too long to realize that -3 and -4 will work for that. So factoring is actually the best and quickest method for option C. And then D, sometimes people think because it's got two terms that it should be square root, but notice this has an x in it. So this is actually factoring, however you want to do that. We've talked about how we should take a GCF out, and notice that on this one, I am going to talk through this one for a second. If I take a GCF out, 5 and x both go into that. So if I undistribute, that's going to give me x -9, and that's already factored. So from that point, you can give your two answers of x equals 0 and x equals +9. Remember, anytime an x is not inside parentheses with something, it's going to give the root 0. All right, so let's look at our word problems now. All right, so instead of labeling your notes about this, choose the solution methods for quadratics, that's not really what you're doing here. I would label this section word problems or modeling quadratic equation word problems, because we're going to talk about how to write those equations. All right, so there's this general formula for quadratics, and it looks like this when we talk about quadratic word problems. It's this h equals -16t squared plus vt plus s. And there's some things there that you need to know. And you'll learn this later on in high school also, but this -16 right here, that's the constant acceleration of gravity. And basically that means that like the weight of something, just gravity itself, is going to cause something that you drop to increase at a rate of -16 meters per second squared. I know you've probably heard before that if you like drop a penny from the Empire State Building, it could kill somebody, and that's because it's taking so long to fall that it's speeding up 16 meters per second every second that it's falling. So by the time it hits the ground, it's going crazy, crazy fast, even though it's super, super small. The V here is going to stand for initial velocity, which is like the initial speed that the item started. So for instance, if you're throwing versus just dropping that penny, right? Like if you drop it, you're obviously not caught putting any force on it, but if you throw the penny down, you're already starting it with speed. So that's what that V is going to stand for. And then the S here at the end, hopefully you remember that this variable, not variable, but this value at the end is going to be your y-intercept. So it is your starting height. All right, so make sure you have that written down, and then we're going to try this word problem together. Okay, so in this problem, if you want to just write it as, you can just write out the entire word problem. We're only going to do one, but if you need to write bullet points for the information given, you can do that too. Whatever you think is going to be most helpful for you to have in your notes. So it says Marco is throwing a tennis ball at a kite. So he's going to be throwing the tennis ball up because it looks like the kite's stuck in a tree. So I'm going to underline the kite is stuck in a tree 42 feet up in the air. He's trying to knock it loose. He can throw the ball at a velocity of 45 feet per second upward. So that's going to be a positive velocity because it's moving up at a height of 4 feet. That means he's going to start, or the ball is going to start 4 feet off the ground. So let's start by writing an equation for that. And my general equation is going to be that h equals, that's the height of the ball at any given point in time. H is going to equal the initial, so the constant, negative 16 t squared, plus his velocity, so plus 45 t, and the ball is starting at 4 feet off the ground. All right, so that's my general equation. All right, if you aren't sure how we got that, then you need to rewind and rewatch that section. So now we need to talk about how can we actually solve this problem. And since this is a word problem, to me, I think it's going to make probably more sense to use a calculator. All right, so like we've done in the past, we're going to use y equals. So I'm just going to type this equation into y equals. And if I want to know if his throw will reach the kite, what I really need to know is, so just kind of imagine what's happening here, right? We've got a guy, he's throwing a tennis ball up into a tree. It's beautiful, right? And there's a kite up in the tree, and he's trying to see if it will reach. So know that his ball is, like, the ball is going to go in this parabola path. That's why we're modeling it by a x squared function. So our question is it going to reach that highest height? Or basically, what is the maximum? So if I type that in y equals, I got these values. I'm going to kind of cover this up. Notice I ended up having to zoom in to really see. But for me, the maximum, it looks like happens somewhere around 1.4 seconds, and it's somewhere around 35.6 feet high. Well, since the kite is 42 feet up in the tree, the answer is no. His throw is not going to reach that kite. So then the follow-up question is, at what speed does he need to throw the ball so that it will reach the kite? Okay, so let's take a second to wrap our head around this. We have our formula, and I've taken out the velocity here because I don't know what it's supposed to be. That's what we're trying to figure out. And I've set our equation equal to 42 because I want the height of the ball to actually get to 42. That's what I'm looking for. So if you think about it, I want an answer that is the maximum. So when the solution or the root, equals the maximum, all right, if you remember, that's what looks like this, or maybe like this. The idea is that the maximum or minimum and the root themselves match, and that happens when we have a double root or when the square root, the discriminant part, equals 0. So I want 0 underneath that square root. So I'm going to go ahead and set this up. My a is negative 16. Oh, before I do that, what am I doing? It has to equal 0 first, so I'm going to subtract this 42. All right, that's going to give me negative 16t squared. Should put a tail on that, plus some unknown value t minus, what is that, 38 equals 0. That's going to tell me that a is negative 16. B, I don't know, so I'm just going to call it b in my equation. And then C is negative 38. So I want to set this up. And I'm going to have b squared, which I don't know, so I'm just going to write b squared minus 4 times a times c. And I want this to equal 0 so that the maximum is the answer. All right, and that's giving me b squared minus 2,432 equals 0. This is easiest to just solve by taking square roots, so b squared equals positive 2,432. And then I'm going to take the square root of that. And since we're doing word problems here, you can take the square root using your calculator. It's okay to get a decimal. Nobody's going to want to break that down. Even I don't want to. So it's going to be equals. Now, we could do, I'm going to write plus or minus, and then we're going to talk about which one it actually should be. 49.3. So this question, remember, is asking how hard should he throw the ball. So if he throws it positive, that means he's throwing the ball upward. That's going to be the positive 49.3. If he throws it negative, that means he's throwing the ball downward at 49.3. Well, it's not going to make any sense for him to throw the ball down. That's not actually going to hit the kite that he's aiming for. So the answer is that his throw should be 49.3 meters per second, and it should be, or sorry, I think feet per second is this problem. Feet per second, and it should be positive. That should be his initial starting velocity.